Hello and welcome. This is module 2.8 of the term 2 syllabus of book 2 of Peter Robson, approximations, decimal places and polygons. I did this in class and most of you understood it first time. So I'm just going to briefly share a few notes on these things. I'm using my mobile phone today. So the screen is quite small, but on your size it will look big, but for me it looks quite small. Let's look at approximations. For example, if I have the number 15, okay, and I said to you I want to approximate it to the nearest 10. So the question is 15 closer to 10 or is it closer to 20? So naturally, if a number has 5, 6, 7, 8 or 9 as their units, i.e. this has 5, then you go up, you round it up, so it becomes 20. So 15 is actually closer to 20. Now if I rub this out, and I say, what about 16? Then you say, yes, 16 is closer to 20 rather than 10. Makes sense. However, what about if I say 13? Then is 13 closer to 20 or is it closer to 10? Actually, it's closer to 10. Why? Because it's below 5, 6, 7, 8, 9. Okay. Let's move this out of the way and try another one. What about 27? Which 10 is it closer to? To the nearest 10. Is it closer to 30 or is it closer to 20? You look at it carefully and you go, oh, this is a 7. So 5, 6, 7, 8, 9 units mean you go up. So it's closer to 30. So let's try 78. To the nearest 10, is it closer to 70 or is it closer to 80? You've guessed it, it's closer to 80. Because the 8 rounds it up towards 80. However, if I said to you to the nearest 100, is 78 closer to 100 or is it closer to 0? You would say you round it up to 100, it's closer to 100. So this is what approximations does. It's rounding to the nearest 10, to the nearest 100, or to the nearest 1,000, or even 10,000. For example, if I have 50, is this closer to the nearest 100, or is it closer to 0? Because it's a 5 here, and is exactly halfway, we say 100. If it's 49, we say 0. It's closer to 0 than 100. What about 3, 5, 1? To the nearest 10, what is it? Yes, it's 350, because 51 is closer to 50. To the nearest 100, well, 3, 5, 1, and this is 51, and that's a 3, so it makes it 400. It's closer to 400. And then what about nearest 1,000? Well, 351 is less than 500, so it's closer to 0. So closest to the nearest 10 is 350, to the nearest 100 is 400, and to the nearest 1,000 it is 0. Here's the next one. What about 499? To the nearest 10 is what? It's 500. Because this gets rounded up, it's closer to 100, so this becomes 500 to the nearest 10. What about to the nearest 100? It's still 500. What about to the nearest 1,000? What about to the nearest 1,000? Yes, you guessed it. It is 0. Because it still has not reached 500 and above, so it's closer to 0 than to 499. Right, that's enough of approximations. Let's go into decimal places. So DP means decimal place. So I'm just going to draw something here. Very tiny. And this is 1. And this is 2. And this is DP basically, decimal place. So if I have 56.2, to 1 decimal place is 56.2. To 2 decimal places is 56.20, because you have to put a 0 in to represent the second decimal place. If I say 1.76 to 1 decimal place, it will be 1.8. Why do you say 1.8, Deepesh, Mr. Patel? Because look, this is the first decimal place and this is the second. So you look at the second to judge the first. And you say, is it closer to 70 or is it closer to 80? 76 is closer to 80. Or this 6 is above 5. So anything 5, 6, 7, 8, 9 rounds the next number on the left up. So that's why it's 1.8. But to 2 decimal places is 1.76. I hope you get the picture. Let's move it up slightly. Let's go and do 2.99. Sometimes we get confused on this. Now we look at the number 9. So that means this goes up by 1. So it becomes 3.0. And 2 decimal places is 3. To 2 decimal places actually is 2.99. It just remains the same because that's in 2 decimal place format. What about if we try this one? 3.749. To 1 decimal place, look at the 7. Should it remain 7 or should it go up? You look at the next number. Oh, it's a 4. So it should stay the same. It doesn't go up. Meaning it's closer to 3.70 rather than 3.80. So that's 1 decimal place. 2 decimal places will be, 3.74. Is it closer to 3.74 or 3.75? You look at the next number and it's a 9. So it goes up 3.75. And that's decimal places in a nutshell. I don't really need to give you sample questions for approximations and decimal places and polygons. It's quite straightforward. Just look at the video and you'll get an understanding of what type of questions I'm going to ask. The next slide. So now we're going to do polygons. Really easy subject. Poly means many, so polygons, many-sided shapes. Mono means 1, poly means many. Right, we have triangle, yes? That's a polygon. 3-sided. We have a square or a rectangle. This is called a quadrilateral and it's 4-sided. So that's 3, 4. What's 5-sided? Yes, you guessed it. 5 is a pentagon. 6 is hexagon. 7 is heptagon. 8 is octagon. 9 is nonagon. And 10 is decagon. Okay, you only need to know up to 8, 9, 10. Yeah. Everyone knows 3 is a triangle. 4 is a square or rectangle. And it's called a quadrilateral. 5 is called a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. And 10 is a decagon. Okay. Now, there is something you need to know, and it will come up, the differences between irregular that is an A, irregular and regular polygons. And it will be tested. I will give you a picture of many polygons, and you have to decide which type of polygon it is and state if it's irregular or regular. So I know this is rough drawing, so let's just put it up like this. For example, here's a square. Roughly, it's a square. And then so both shapes are four-sided. So they're quadrilaterals. Quad means four. So both are four. But this square, roughly, I'm just drawing it roughly, is a regular square, a regular polygon. And this one is irregular. So I'm just putting I-double-R here so you know it's irregular. So in the test, you're going to get pictures of polygons, and you have to state what the polygon is. Is it a hexagon? Is it a heptagon? Is it a nonagon, decagon? Is it a triangle? Is it a square? You know, basically, is it a pentagon? And then you have to state if it's regular or irregular. The difference is regular means all the sides are the same length and the angles are the same. So here 90 degrees, 90 degrees, 90 degrees. Irregular angles are quite different. They're not the same. And the length is different of all four sides. Okay. So regular means they're the same length of the sides and the same angles, and irregular, different angles and different lengths. And that's it with polygons. And that's what's coming up this Saturday. And just practice, practice, practice. Just to briefly summarize again, you need to know, let's go to a different slide. When it comes to approximations, so let's just put A for approximations. You need to know up to 10, up to 100, up to 1,000, and probably 10,000. Okay? I'm not going to give you a sample of what questions are going to come up. It's a very simple topic. You just have to now understand how to approximate any number from 10, 100, 1,000 and 10,000. Decimal places, we're going to just do 1 dp, 2 dp and 3 dp. 3 decimal places. And with polygons, you just need to know 3-sided shape, 4-sided shape, 5-sided shape, all the way to 10. So just recognize it. It's very simple. Count the number of sides and know the difference between a regular and an irregular polygon. Regular, all the sides are the same length and the angles are the same. And irregular, all the sides and the angles are not the same length. Yeah, they're not the same length, all of them. And that's it. Good luck and see you this Saturday.